Welcome to Coach Action Math. Today we'll be talking about similar polygons. So, as we first start talking about similar polygons, it is important that we recognize that similar polygons are the same shape but different size. Okay? So, the way we talk about similar is you're going to see a tilde mark there. That would be the same shape. You have seen this before when we talk about congruence. When we talk about congruence, it's the same shape and the same size. Talking about similar, there's no same size, it's just the same shape. So go ahead and sketch yourself two triangles that are approximately the same shape. Again, it's a sketch, does not have to be perfect. If two polygons are similar, two things are true. Corresponding angles are congruent, and corresponding sides are proportional. Okay, look at example 1. Using the following figures, answer the questions that follow. Angle A would be congruent to angle X. Segment BC would be proportional to segment YZ. Angle B would be congruent to angle Y. Segment AB would be congruent to segment XY. Sorry, not congruent, but proportional. And angle C would be congruent to angle Z. Looking at CA, CA would be proportional to ZX. Or you could write XZ as order when you're naming a segment does not matter. Looking at example 2, if the quadrilaterals are similar, then what must be true? About the angles, we know the angles are congruent, and we know the sides are proportional. Okay, so just an example of how to write that, we'd say angle A would be congruent to angle E. Angle B congruent to angle F. Angle C congruent to angle G, and angle H congruent to angle D. Okay, talking about proportionality, AB will be proportional to EF. And again, we're talking about segments, so make sure you put your segment there. BC, segment BC will be proportional to segment FG. Segment CD is proportional to segment GH, and segment AD will be proportional to segment EH. As you finish up with this one, go ahead and flip it over. Looking at example 3, I want you to go ahead and pause the video and please try this one on your own. Welcome back. Talking about angles, our three angles, we should say angle L is congruent to angle R. Angle M is congruent to angle S, and angle N is congruent to angle T. You could have also not only looked at the pictures, but you could have looked up top. L and R are the first letters, they go together. M and S are the second letters, they go together. And N and T are the third letters, they would go together. Notice how those angles work out. So again, talking about sides, segment LM proportional to segment RS, segment MN is proportional to segment ST, and then segment LN is proportional to segment RT. Should be finding those things proportional and those angles congruent. Again, the easiest way to do that is to use your similarity statement, just like we did when we were talking about congruent statements. Looking down below, a very important term to know when talking about similar polygons is the word included. An angle is said to be included between two sides, and a side is said to be included between two angles. So looking down at example number 4, which angle is included between segment AB and segment BC? The angle between would be angle B. Notice angle B is in both of your segments. Which side is included between angle E and angle D? Well, the segment between there would be the segment And which angle is between AE and AB? That would be angle A. Again, please pause the video, see if you can do example 5 on your own. Welcome back. Looking at example 5. Angle between AM and MC would be angle M. Between angle A and angle M would be segment AM, and between angle A and angle C would be segment AC. So, looking on to the last page, talking about a common ratio. Okay, talking about a common ratio, the ratio between the lengths of sides of two corresponding sides. The lengths of two corresponding sides, right? Pardon me for getting ahead of myself there. Common ratio is the ratio of the length of two corresponding sides, or all corresponding sides, as we will find out with the perimeter later. If we look at it, the important thing I want you to know is we're always going to put the new on top and the old on bottom. So the way to know is when you look at your picture, we're always going to work left to right like we read and call the first one the old one and the second one the new one, unless they tell us different in our problem. Looking down below, it tells us what is the common ratio of ABCD to EFGH. So right here, they tell us this one to the other one. This would be the old, and this would be the new. So in this case, we've marked them okay just by looking at the picture, but make sure you read your problem as well to know which one goes on top and which one goes on bottom. Okay, so looking at the common ratio, AD, segment AD would be proportional to segment EH. Okay, notice the old went first, the new came second. Another way to say that would be 10 to 5 or 10 over 5, which simplifies down to 2 to 1 or just 2 since it's 2 divided by 1. That would be our common ratio in example 6. Show that the ratio of the perimeters is the same as the common ratio. The perimeter for A, B, C, D, when you come up here and you add them all together, 10 plus 8 plus 6 plus 5 would give me 29. And remember, that is my old shape. My new shape, I'm going to find the perimeter of EFGH. When I go find that, 5 plus 9 plus 3 plus 2.5 would give me 14.5. So, again, we're going to say old over new. The ratio there is 2 over 1 or just 2. Notice, the ratio for the perimeters is the same as the common ratio. Looking down at example 8, this is what I told you to be careful of. All they've done here is take and say EFGH is now my old and ABCD is now my new. So instead of saying 10 to 5, I'm going to say 5 to 10 or 5 over 10. And yes, the order matters because now I have a ratio of 1 to 2 or a ratio of 1/2. It's another way to say that. So please make sure that you're being careful. Listen to the new on top every time as you're going through. Appreciate you watching. Hope you have a great rest of your day.